Hello fellow game makers and welcome to a new series of tutorials on shaders. Ever since they've been introduced in GameMaker, shaders have been very popular. But unfortunately lots of people want to use them, but only few people can create and write them. Luckily there are some sites on the internet that offer libraries of shaders for you to look at and be inspired by. Unfortunately, all of those sites handle shaders a little bit differently from how GameMaker does. So in these tutorials I want to show you for the different sites how you can adapt the code so that the shaders work in GameMaker. We will start with Shadertoy, one of the most popular shader sites on the internet, and I've picked two shaders that, if you combine them, really create a nice underwater effect. Here is what we're going to create. As you can see, a couple of things are going on here. For example, the seaweed is distorted by the waves of the wave shader. Also the fish are distorted by the wave shader, and if you look closely you can see the Godrays that come through the surface of the ocean. Also the performance of these shaders is really great. If you look at the frames per second here with all the shaders activated, and now I switch them off, you can see that without the shaders it's basically as fast as with the shaders. Before we get started, I want to point out the website of xorshaders.weebly.com. He's one of the great guys when it comes to GameMaker and shaders. He knows all about them and how to actually write them, something that I don't. And I really highly recommend his tutorials. In fact, his tutorials were also one of the main sources of information when I created this video. Now let's have a look at Shadertoy. In Shadertoy I found this nice Godray effect that not only is beautiful, but also is very small. If you look at this, there is no scroll bar here. This is all of the code needed, and also it doesn't use any textures as input sources. That would make things a little bit more complicated. That's why we'll only talk about that in part 2 of this tutorial. But for now, let's actually get started with this shader. Before we do, however, one more disclaimer. Even though there are no mentions of licensing in this code, Shadertoy puts a standard license on all of the code that's posted there. And this license does not allow commercial use. So if it's not stated otherwise, you are not allowed to use this code in a commercial product. You would have to contact the author of the shader and ask for permission. With that out of the way, let's actually get started. First things first, you just copy the whole code. And it's important to also copy the inputs up here. Even though we won't need all of them, I always copy the whole block and put that in here as well. Now we don't need to come back to Shadertoy, so let's switch to GameMaker. All I have so far is a simple room with a background and two fish swimming around. No light effects, no wave effects, no nothing. Now let's add a shader. Right click on the shader folder here and select create shader, and what you get is a simple pass-through shader. That means that this shader, even if you apply it to geometry, won't do anything. The geometry will look exactly as it did before. Let's go through the very basics of shaders just very quickly to get you up to speed. This is the vertex shader. That can change the position of the corner points, the vertices of your geometry. We don't want to do that, so we can skip it. The fragment shader is what actually modifies the color of the pixels on the screen, and that's what we want. And after all the calculations are done, this variable here, glFragColor, that contains the final end result RGB alpha value that is then used to draw the pixel on the screen. So somehow at the end of your code you need to modify this variable. Let's name this shader Godrays, and let's get rid of this main method in here, and let's instead use the code from Shadertoy. The first thing I would advise you to do is to format this code in your own style. Everybody codes a little bit differently and uses different line indentations, so let me just go through this and I'll be back in a second. Okay, I haven't changed any of the content of the shader yet. I've just gone ahead and changed a bit of the formatting. Before I actually start using the shader in an object, what I first want to try and do is get it to compile. And I could now go through the shader and already modify all the things that I already know won't work, but I think it's better to have a look at the compiler errors together and then see how you can fix them so that you can use the same fixes if the error comes up in your own projects. So let's see what happens if I just start to compile the project as it is right now. It says that there is a syntax error in line 15. Let's have a look at that. Well, one thing that you can remember from now on is that as of the current version of GameMaker, the compiler always throws the arrow at one line off the actual error. The error is in line 14 and it's reported as being in line 15. What GameMaker doesn't know is this sampler XX variable type. GameMaker knows sampler 2D and sampler 3D, but it doesn't know sampler XX. So we will need to get rid of that. And also, this already brings me to the next important point. These are all the input variables that Shadertoy creates by default, but most of them aren't actually even used in this shader. So what I would advise you to do is open the Find and Replace bar and take each of those variables and check whether they actually come up in the code. For example, iResolution seems to come up quite often. What about iGlobalTime? That also appears. But iTimeDelta, that already doesn't even appear in the code, and I already know that all of them actually don't appear, so we can get rid of all of them. That should get rid of that error in line 14. Let's see what's next. The compiler complains that there is no main method. Let's have a look at that. Indeed, in Shadertoy, the main method is called main_image, and GameMaker doesn't know that. So you have to replace this main method here by void main, and that should now work. Let's have a look at the next error. GameMaker tells us that it doesn't know the variable frag coord. It says that's an undeclared identifier that we haven't defined. Let's have a look at what that means. As you can see, the frag coord is used quite often in this code, and what the frag coordinate actually stands for in Shadertoy is the current x and y position of the fragment or the pixel that you're trying to modify. And indeed, GameMaker does not supply this variable in its standard pass-through shader, so we have to create it. Let's copy the name, and this is a varying vec2 with the name fragCoord. Because it's a varying, we also have to create it in the vertex shader, and here we actually also set its value. So in the main method of the vertex shader, let's add a new line and set the frag coord to the in position.xy. The in position is a variable that's supplied by GameMaker that contains the current XYZ position of the point that the shader is working on. And if we pass that into the variable frag coord, it can then be used by the fragment shader to do its calculations. Let's see whether there are still errors left. Now GameMaker complains that frag color is an undeclared identifier in line 55. And as you can see, that is actually correct. I've told you before that GameMaker uses the variable GL_frag_color as the final output for the RGBA value of the pixel that it's working on. In Shadertoy, this is used frag color, so we have to replace it by GL_frag_color. So whenever you see frag color, replace it by GL_frag_color. One more try. Aha, no more compile errors. So now we can start implementing the shader and using it in our game. I've already prepared an object for that, object VFX, but it's completely empty. And a couple of things first. We want to create a full screen shader. The place to do that is in the post draw event, because this event runs after all of the draw events have been processed, but before the graphical user interface is drawn. So that means that our wave effect, or the Godray effect in this case, will affect everything that's drawn on screen, but not the graphical user interface. So let's just put an empty code block in here for the moment, because we need to do one more thing. If we were to write our shader code in here, we wouldn't see anything in the end. The reason is that GameMaker uses the so-called application surface. The application surface is created and filled while all the objects are being drawn. So first the backgrounds are drawn to it, then the objects are drawn onto it. Perhaps there's also a foreground. So all of those elements are combined and prepared in the application surface. And once that is done, at the end of the post-draw event, GameMaker draws the finished application surface to the screen. So whatever we write in here, right now we wouldn't see it, because at the end of the post-draw event it would be overwritten by the prepared application surface that GameMaker has created. So what we need to do is we need to stop this automated drawing from happening. And we do that in the create event. The line to stop the drawing is application surface draw enable false. From now on, GameMaker will still create the application surface and fill it with all the data and pictures and backgrounds and everything, but it won't automatically draw it at the end of the post-draw event. So if we have a look at the game now, we'll see that it's just blank because the application surface isn't being drawn. If we want to draw it by hand now, we can go into the post-draw event and just call draw surface as we would with any other surface, but in this case the surface that we want to draw is a special one. It's the application surface. At position 0, 0, and now the game looks as before, but we now have the control over when the application surface is being drawn. So let's comment that out and let's have a look at how you can actually draw the shader. To draw the shader, you need to call shader set and then the name of the shader. To finish drawing with the shader, you have to call shader reset. Everything that you draw between these two lines is actually drawn with the shader applied to it. In this case, what we want to do is we want a full screen effect with these Godrays, so we need to make sure that we draw something that is full screen, whatever that is. So it's enough to just draw a full screen rectangle and the shader will be applied to that. So let's do just that. Let's draw a full screen rectangle from 0, 0 to 800 by 600, and we don't just want to draw the outline, but the whole rectangle. So now we draw a rectangle and the pixels will be modified by the shader to create the Godray effect. Let's see how it looks right now. You can see that something has happened. Some rays are being created, but the rays do not animate and they are not in the correct position. The reason for that is that in the shader code we have these input variables here. One is called iResolution, which is the resolution of the viewport in pixels, and one is called iGlobalTime, which is how long has the shader been playing in seconds, for example 0.5 or 1.5. These are called uniforms, and you have to supply the values for these uniforms outside of the shader code. Let me show you how that works. We'll start with iResolution. This is a vec3 right now. Actually, it doesn't even need to be a vec3 because it only contains two values, the x and the y resolution, so we can actually change that to a vec2. So it is a variable that stores two floating point values. The first thing we need to do is we need to take this variable and make it available in GML. We do that in the create event by calling shader get uniform. You have to tell it which shader you get the uniform from, and you have to tell it the name of the uniform in the shader. That's a string and it's iResolution. And now you have to save this uniform in the GameMaker language, for example, resolution. And now whenever you want to access this uniform in the shader, you just call resolution. You need to do the same for the global time. global time, we'll call that seconds. We also need to create a variable that actually counts the seconds up while the game runs. So I'll call that sec and set it to 0. And in the step event, I'll just increase this by 1 divided by room speed. So for example, if the room speed is 30, this will be increased by 1/30th 30 times a second, so that means that it is increased by 1 every second. And now let's actually set these uniforms after we have set the shader, before we draw with the shader. So let's write shader set uniform. And as you can see, you can now choose from a bunch of different uniforms: floating point arrays, integer arrays, and so on. What we want is a float, so _f. Now we need to supply the name of the uniform, that was resolution, and the values are 800 by 600. Since these are floating point values, I have to add 0.0, 0.0. And we do the same for the seconds, and that is whatever the current value of the variable sec is. So that starts at 0 and it counts upwards, and the current value is used to animate the Godrays as time goes on. Let's have a look at the effect now. The Godray effect is already looking quite nice, but for whatever reason it comes from the bottom up and not from the top down. Now, it took me some time to figure out why that was the case, and I still can't really explain it, but in the code of the fragment shader, the person who created this shader first creates a vec2 called uv, where it copies the frag coordinate into, but then this uv variable never appears again. So we can actually get rid of those two lines. And here another vec2 is created named chord, which is actually later used to calculate the brightness of the individual pixels. And here he subtracts the y resolution, so in my case 600 pixels, from the current y coordinate of the pixel that's being worked on. And that in essence flips the picture upside down. I'm not sure why that is being done, because in Shadertoy the image wasn't flipped upside down. I can only imagine that it has something to do with GameMaker having the y coordinate 0 all the way at the top, whereas perhaps in other programs it's at the bottom. So if we just get rid of this part here and just use the real y coordinate of the pixel that's being worked on without flipping it around, the end result is the Godrays now coming from the top. The last part is to apply this shader on top of the existing image. Let's do that. In the post draw event right now we only draw the shader, but we can also draw the application surface before. We now have our background with the fish, everything on the application surface, and then this nice subtle Godray animation on top. In part 2, I'm going to show you how we can then add the wave effect to the application surface. That's a little bit more complicated because we need to feed a texture into the shader, and I'm going to show you how you can do that. And also the shader is much more complex, so we'll have to go through more compilation errors. Grab a snack and then come back for part 2.